Hello guys. So we are done with the first chapter, chapter 5, and we are moving on to chapter 6. I like chapter 6 because it's all about polynomials, and we're going to add polynomials, subtract polynomials, multiply polynomials, and then we don't call it dividing polynomials, but we call it factoring polynomials. Okay, and you're probably wondering, what is a polynomial? It's just a fancy word for something you've already been dealing with in algebra and pre-algebra. You guys know what a polynomial is. You just didn't realize you knew. So a polynomial is anything with a number in front. So it's a letter with a number in front. That's the coefficient, the variable or the letter. It has exponents, which we've worked with. It has subtracting. It has adding. It's any of these things. So this is a polynomial. And then the other polynomial is right here. Okay, so it's anything with adding and subtracting in between. So at this point, you might want to just pause the video and write these two examples down. This is example 1, part A and B. You can write them down and then, see if you know how to add them already. If not, I'm going to show you. So how we add polynomials is we first need to figure out, are we adding or subtracting? Because I'm going to show you how to do both today. So see in between the parentheses here, this is one polynomial and this is another polynomial. And in between, we're adding. Here's one polynomial, here's another polynomial, and in between we're adding. Later on, it'll be subtracting, and I'll show you how to deal with that. But we want to make sure it's plus first, okay? We can't start the problem until it's plus first. So now you're just going to look and see what goes with what else. So x squared goes with x squared, and it stays x squared. X to the 5th goes with x to the 5th, and it stays x to the 5th. X goes with x, and it stays in x. Okay, so you're looking for what has the same exponent. Okay, we're going to look for the biggest exponent just so we can keep them in order. I like to keep my largest exponent first. Okay, so I'm looking at all of these different terms. I've got 6 different things. Okay, hopefully you can see those. Let me bring you in a little bit closer. Okay, so we've got 6 different terms, and we need to see what matches with what. So this has a x to the 3rd, x to the 2nd, no number, but we know that's an imaginary 1, x to the 2nd, x to the 3rd, and this doesn't have an x at all. Okay, so I see the largest exponent I have is x to the 3rd. I'm only looking at the small little exponents right now. X to the 3rd goes with x to the 3rd. So this one goes with this one. Now what I'm going to do is I'm going to add those exponents. Okay, so 2 plus, and there's no exponent here. Okay, so, or sorry, not exponents. I'm adding the coefficients. 2 plus the number in front here. And if there's not a number in front, it's a 1. So 2 plus 1 is 3, and it stays x to the 3rd. So x to the 3rd goes with x to the 3rd, and then it stays x to the 3rd. Okay, the only number that changes is the number in front, and you add them because it tells you to add right here. Okay, let me move you back out. Okay, there you go. The glare's gone now. Okay, so now I'm just going to do another color so you can see how they're color-coded. If you don't have more than one color, that's fine. You can just do 2, like underline it twice instead. Okay, so now after x to the 3rd, it goes down to x to the 2nd, right? So now I'm looking for anything with x to the 2nd with a little 2 power. Here's x to the 2nd, and I'll put 2 lines under it. And here's x to the 2nd, and I'll put 2 lines under it. Those go together. X to the 2nd goes with x to the 2nd, and it's going to stay x to the 2nd. And we're going to add the numbers in front. Now be careful. This is a -5. So -5 plus 2. That's like you borrow $5, and for some reason you only have $2 to pay me back. So you still are going to owe me money, so you're going to be negative. And how much are you going to owe me? You're going to owe me 3. So you're -3, and it stays x squared. Notice that the x squared does not change. X squared goes with x squared, and it stays x squared. Okay? So now I'm going to grab another color, and we'll do a 3 line for this one. So after x to the 3rd, then we go down to x to the 2nd, and then we're going to go down to x to the 1. Well, we don't put the 1. So anytime you see an x, just remember that there's like a little imaginary 1 up there as well. There's also an imaginary 1 right here, okay, that you can put here. So there's nothing else to buddy up with it. This doesn't have an x. So we're just going to keep this as 1x, or not even put the 1 at all. Okay, usually you'll see no 1 at all. Like that. So that one was kind of all by itself. There was nothing to buddy up, so we just rewrote it. The next one is just no x's at all. So we go x to the third, x to the second, x to the imaginary first, and now we go to no x. And there's only one thing with no x, so we just rewrite that. If there was 2, we would have put them together. Okay, so why don't you try the second one? I'll pause the video right now, and or you can pause the video right now and go ahead and try it, and then I'll come back and help you work through it. Okay, so now we're going to try this one out. So we first make sure we've got our 2 polynomials. We want to make sure there's a plus in between. Okay, if there's not, I'll show you that in a minute. But there is a plus in between, so we're going to add them. So we're going to look for the exponents that are matching. We're looking at the small numbers, not the big numbers. Okay, the small exponents, not the big coefficients out in front. So out of all these exponents, we only see a 2. That's the biggest number. So x to the squared, x squared goes with x squared. It's going to stay x squared. That's why we're budding them up, because they both have an x squared. Now we're going to look at the coefficients in front and add those. 3 plus an imaginary 1 is 4, and it stays x to the second power. Okay, x squared goes with x squared, it stays x squared. And they don't have to be far apart. They could be right next to each other. It doesn't matter where they're at. We're just looking for any x squareds and putting them together. Then after x squared, we do x to the first. Sorry, my video cut out. So we're going to go x to the first with x to the first, and those are going to get buddied up. So I have an x by itself and an x. Okay, I'm going to put 2 lines under those because those are buddies. I have 1 plus 4, so that's positive 5, and it stays in x. X goes with x, and it stays in x. Okay, then I'm moving on to my no x's. Okay, so I go from x squared to x to no x. No x goes with no x, and those are buddies, so I'm going to put those together. And I've got a negative 6. So negative 6 plus 10, or I borrowed $6, but I look in my wallet and I have a $10 bill. So I can pay back the debt, and how much money am I going to have left? I'm still going to have positive $4 in my wallet. So now you've just combined them. They don't have to be in order like this. These two, these two, these two, they can be anywhere. So just make sure that x squared goes with x squared and it stays in x squared. X to the 5th goes with x to the 5th and it stays in x to the 5th, whatever it is. Okay, so now we're going to work on example 2, and you'll see you have a polynomial and you have another polynomial, but you have a minus in between. Same thing with this one. So before you start, if you have a minus in between, you can do 2 things. You can remember to subtract everything. So you would be subtracting a negative 2, subtracting 2, and subtracting a negative 4. Now you can see how that gets confusing. People forget to do the subtracting all the way through, and they mess up on the double negatives. So what I've noticed in the past is it's a lot easier just to change it to a plus sign, and then you don't have to worry about the double negatives. So if you have a minus in between the 2 parentheses, you change it to a plus. Now, wouldn't that be great if we could just change it to a plus and not change the problem? Well, we are changing the problem. So if we're going to do that, we have to change all the signs after it. It's kind of like distributing a negative through. So this negative has to become a positive. This positive has to flip to negative. And this negative has to flip to positive. So if you flip this symbol, you have to flip everything and distribute it through. But now it's made our problem a lot easier because now we can add. Same thing down here. If this is a minus, you can change it to a plus, but everything after it has to be changed. Now, we don't change anything up in the front. Anything that's after it, though, has to be distributed. So this positive 3 becomes a negative. This negative becomes a positive, and this negative becomes a positive. And now we're ready to go. It's the exact same thing as example 1 now. And you just put your variables with each other. So we're looking for the largest exponent that we have. So if I look through all these exponents, the biggest one I see is 2. N to the second power, it goes with n to the second power, and it's going to stay n to the second power. So 4 plus 2 now. Remember, it used to be a minus a negative. Well, when you're minusing a negative, that's a double negative, so it becomes positive, and we've already fixed it there. So 4 plus 2 now is 6, and it stays n squared. Do not change the n squared. Do not add 2 plus 2 and make it 4. N squared goes with n squared, and it stays n squared. Okay? The next one. After n squared, we're going to move on to n to the first power. So I'm looking, the only spot that I see an n to the first power is right there. Let me grab a different color. I'll put 2 lines under it as well in case you don't have colored markers or pencils. I only have 1, and it's negative 2 now. We've switched it. So I'm going to put minus 2n. I can put plus a negative 2n, but it's extra. Okay, and there's nothing to buddy up with it, so it's just going to hang out there where it is. After that, we do no n's. So we do n to the second power, n to the imaginary first power, and then no n. So no n goes with no n, and obviously it stays no n. 5 plus 4 now is positive 9. And that's your answer for that one. Okay, so now for the next one, same thing. We've already changed all of the opposite symbols. So all the negatives became positive and all the positives became negative. And now we're going to do the same thing. X squared goes with x squared, and it's going to stay at x squared. And that's my largest exponent that I have. So x squared goes with x squared. 4 plus a negative 3 or 4 take away 3. It doesn't matter. 4 take away 3 is 1. So we have 1x squared, but we're not going to write the 1, okay? You can put the imaginary 1 in there if you want, but it won't be there on the test. After x to the second power, we go to x to the first power. So we'll do that in a different color. X to the first power goes with x to the first power, and it stays x to the first power. So we've got negative 3 plus 1 is negative 2, and it stays in x. And then the last thing would be no x goes with no x, and it stays no x. So no x goes with no x, and it stays no x. So we've got 5 plus 8, which is 13, positive 13. Okay, so now I've showed you how to add, I've showed you how to subtract, and that's all we're doing today. So now go ahead and pause it and copy down these 3 checkpoints. Please try them on your own. Please make sure you are taking notes and you're actually trying these. Just watching me do a bunch of math problems is not going to help you learn. You really need to actually physically get out and write them down and be trying them on your own on paper. If you need paper or anything like that, please reach out to me and I can get you hooked up at the school. We have all that stuff. So at this point, try it, and then I will show you how to help to get through it if you are having trouble. So for the first one, we've got, kind of everything all over the place, which is okay. You just want to make sure you start with the largest exponent first. So I'm looking at the little exponents. I have a 3, an imaginary 1, a 2, and a 3. So my biggest exponent is x to the third. So I'm going to start with x to the third. So x to the third goes with x to the third, wherever they are at, okay? X to the third goes x to the third, and it stays x to the third. So 5 plus 3 is 8, but it stays x to the third. Don't change the exponent. After x to the third, we go to x to the second. So now I'm looking for x to the second. Oh, and before I started, I made sure I had a plus in the middle, because be careful, some of them don't. Okay, heads up. So after x to the third, I go to x to the second. So the only time I see x to the second is right there. There's nobody to buddy up with it. So it just hangs out by itself. So it's a positive 4x to the second. We don't change it. We just rewrite it into the answer. After x to the third, down to the x to the second. Now we're down to x to the first, or just an x, because the first is going to be imaginary. So x to the first with x to the first, and it stays x to the first. Okay, so 4 take away 2. Well, that's positive 2, and it stays in x. X goes with x, and it stays in x. And then the last thing is after x, we go to no x. And I only see one thing with no x, and it's a negative 6. So I'm going to write minus 6. If there was 2 things, I would buddy them up and add them together. But there's only one, so we just rewrite it. Next one. Next one's a little trickier just because it's got this minus in between. Make sure that there's a plus in between those parentheses before you start your problem. And since there's not, I have to make it a plus. When I make it a plus, I have to change everything after it. Only the stuff that's after it, though. Okay, so I'm going to take that negative and distribute it. So I'm going to make that positive 5 a negative 5. That positive 4 becomes a negative 4, and that minus 9 becomes a plus 9. And now I can do my problem. So x to the second goes with x to the second, and it stays x to the second. That's my largest exponent, so I'm starting out with the x to the second power. 4 take away 5. $4 in your wallet trying to buy something that's $5. You're $1 short, so you're going to have to borrow $1. Now, it does stay x to the second, and we typically don't write the 1. We write the negative, but we leave the 1 out. So if you want to put imaginary 1, you can, or you can just not put it at all. Okay? After x to the second, we go to x to the first. X to the first goes with x to the first. Negative 7 plus a negative 4. So you borrow 7, and then you borrow 4 more. How much do you owe me now? Well, you still owe me money, obviously, so you're negative. And 7 plus 4 is 11, so you owe me 11. Negative 11. And it stays x. X goes with x, and it stays x. And then the last thing is no x. And there's only one of them, so I just rewrite plus 9. If there was 2 things, I would add them together and buddy them up. Okay, and this last one, same concept. We check to make sure it's plus in between, so we're ready to go on there. And we're looking at the largest exponent. So this one actually has an x to the 4th. And that's the largest one I see. So I'm going to start out with x to the 4th. Now, are there any other x to the 4ths? No, so I just rewrite it. 3x to the 4th. There's nothing to buddy up here. Okay? After x to the 4th, I'm going to go to x to the 3rd. I'm going to start the highest and work my way down. So I'm at x to the 3rd. So now I look, and I only have one of those. So I'm just going to rewrite it. 5 plus 5x to the 3rd. If there was 2 of them, I would add them together and buddy them up. After x to the 3rd, we're going down to x to the 2nd. So look for x to the 2nd, and I have one of those. Again, nothing to buddy up, so I just rewrite it, and that's okay. If there's a buddy, you buddy it up and you add. If there's not, you just rewrite the problem. And then the last thing, or not the last thing, we still have 2 more. We have the x and then the no x. So we're going down to x. And again, there's only one of them. So I'm just rewriting negative 3x or minus 3x, same thing. And then the last thing after 4, 3, 2, 1x, now we're going down to no x. No x goes with no x, and it obviously stays no x, okay? But there is a buddy here, so we're going to buddy them up. 7 minus 4. A positive 7, take away 4 is a positive 3. And so that is your answer. Okay, so look those over. If you have any issues with this, go back to the beginning of the video, watch it back through. Sometimes it takes a couple of times of seeing these to really understand them. And then if you have any questions, please reach out to me, and then you should be good to work on the assignment for section 6.1.